All right, let's go ahead and try balancing another one. Now this guy is a little more difficult, a little more involved. And we'll notice that there's no set way to go about balancing reactions. And some students in the past have found this a little frustrating because it's a back and forth. Just like we see in the real world that a teeter-totter goes back and forth, we're going to go back and forth until we get our reaction to balance. So pick an element. Our steps are always going to be the same. Pick an element and go back and forth until you get those two sides, the reactants and the product sides, to balance. All right, well, carbon, why not? We've got a carbon here on the reactant side. We've got two of them in this particular hydrocarbon. Two carbons here, one carbon on the product side. So I'm just going to go ahead, I'm going to put a 2. That'll get us to balance. We now have two carbons. Our carbons are balanced. We put in that coefficient of a 2 to balance. But remember, that 2 doesn't multiply just to the carbon, it multiplies to the oxygen as well. We now have 4 oxygens in there. Well, cool. Let's pick a different element. Why not? We've got hydrogen. We've got 2 hydrogen on the reactant side. We've got 2 on the product side. Hydrogen are good. We don't have to do a darn thing to those guys. Now, all we have left, we balanced the carbons, we balanced the hydrogens, all we have left are our oxygens. Well, on the reactant side, we have 2 oxygens. On the product, we got to get all of them. Well, we've got 2 times 2 here is 4, plus we've got one more over there. One more hydrogen gives us a total of 5 hydrogens on the product side. Ew. Well, no number times 2 can get us to 5. Just can't do it. We can't have half of an oxygen molecule. Well, let's see. Okay, and you're gonna have to take my word a little bit here, but if you ever get stuck like this, I got a tip for you. Let's double the oxygen that's getting us stuck. Well, we could make 2 into 4. Those oxygen are good. We can't make 2 into 1. This guy is getting us stuck. So let's go ahead, let's double this by 2 and see what that does. It's going to change some things, but let's try it. Okay, this 2 now changes the oxygen, but it also changes number of hydrogen. We now have 2 times 2 for a total of 4 hydrogen. Well, if we have 4 on the product side, now we go back to the reactant side. Now we need to multiply this by 2 to make it have 4 hydrogen here. But that changes the number of carbon. We now have 2 times 2. We have 4 carbon here. So wait, there's 1 here we'd need to multiply actually by, not 2, but we'd have to multiply by 4 to get the number of carbons the same. 4 times 1 gives us 4 carbons. 4 carbons here. We've got 4 hydrogen. 4 hydrogen. Now let's double check our oxygen. We've got 2 oxygen on the reactant side. We have 4 times 2. I'm going to go ahead and write this just so I don't get confused. 4 times 2 gives me 8 oxygen here. 2 times 1 gives me 2 more oxygen here. If I add those together, I get the total. For the product side, we've got 10 oxygen total. All right, well, we need to get 10 on the product side to balance the 2 on the reactant side. What times 2 gets you 10? Shouldn't have used your calculator for that one. Should be a 5. Now you'll notice we went back and forth and we changed things until we got it to work. You can always go back and double check. 2 times 2 is 4 carbon. 4 times 1, 4 carbon. We have 4 hydrogen. 4 hydrogen. We've got 10 oxygen. 8 plus 2 for a total of 10 oxygen. These types of reactions are actually one of the most difficult types to balance, and there's no set way to do it. Pick an element, try to balance. Pick an element, try to balance. If you get stuck, double the one that's getting you stuck. Now if you want another tip, something else that I found helpful, you'll notice here we've got a diatomic element, just as oxygen, O2, hanging out by itself. In the event that you're going to balance the equation, I would strongly suggest leave that O2 until the end. Because if you change its coefficient, you change that guy, it doesn't affect anybody else. You know, when we put this 2 out in front here, this first reactant, this hydrocarbon, it changed the carbon and the hydrogen. So then we had to go back and it changed this other side. But if we put the 5 in front of the O2, just gets the oxygen. Doesn't change anybody else. All right, there's another example for you. Feel free to review or replay as many times as you want. It's a back and forth. It's a puzzle to get that balance to come into alignment.